Okay, now members, we are going to see now papygrams. Papygrams are derived from relation. Okay, now papygrams show a diagrammatic representation of the relation being used in a certain mapping. Okay, let us define it and we see how we handle it. Is a diagrammatic representation of a relation within members in a set. This means domain set and the range set all belong to the same set. Now here, in a papygram, they combine elements of a domain and elements of the range into a single set. So consider set A, this and set B. If the relation between A and B is a square of, then A is our domain, so we are squaring this. We get 2 square this, 3 square this, 3, 25, we square 5. So now the relation between A and B is the square of A. So that we are squaring these ones to get B. So B is the square of A. When you square A, you get B. When you square A, you get B. Corresponding elements. Now, the papygram, we are going now to put all these elements in the domain as you see 2, 3, 4. Then these elements in range 4, 9, 25 into one set. Now, after doing that now, note that in papygrams, arrows originate from elements they are referring to, i.e. multiple of, factor of, cube of. Now here, this relation is a square of. So meaning our arrow are not originate from that same square of. Now, you look at this. 4 is the square of 2. So square of 4 is the square of 2. 9 is the square of 3. 25 is the square of 5. As simple as that. So arrows are originated from something they're referring to. Okay, when I come to this, if an element B is related to itself, then the arrow is drawn from itself to itself, i.e. it's like B. If B is related to itself, that arrow will come from B, then it comes back to B. From A, and then it comes back to A. Given sets, let us see some examples now. Given set A, those are the elements. Draw a papygram to show a relation of a multiple of. Now, a multiple of a number, say, let me give you an example. If you have 15 and 2, and 5. 15 and 5. Here I'm going to use this example to explain also a factor. So this number is that 5 divides 15 to get 3. It means that now 15 is a multiple of 5 because we are not having any remainder. And now 5 is a factor of 15. So 5 is a factor of 15. But 15 is a multiple of 5. That's the idea. So we write these elements any random by the way you want. So 5, I have my 6, I have my 3, I have my 9, I have my 12, I have 10 also. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You draw a sample, then you put your elements there. Now, after that, now it's time to, you know that any number is a multiple to itself. So that's what we start with. It means that 5 is a multiple to itself, 6 is a multiple to itself, and so on. So start with that. 5 is a multiple to itself. 6 is a multiple to itself. 9 is a multiple to itself. Then also 3 is a multiple to itself, like that. Then after that, we come to now others. You see, 6 is a multiple of 3. 9 is a multiple of 3. 12 is a multiple of 3. Then 10 is a multiple of 5. Then we are also seeing that 12 is a multiple of 6 because 6 divides this without giving a remainder. And also see, I think that's all. So that's the relation you see. That's the relation we have for all those members. That's the papygram we can draw. When I come to this, the papygram of set B showing the relation factor of. So now a factor is a number that divides a number without giving an remaining factor to a number. But any number is a factor to itself first of all. So we write them randomly. I have 2, I have 3, I have 4, I have 8, then I have 7, I have a 5, I have also a 9. We start with any number is a factor to itself. So that's what we start with. This is a factor to itself. This is the factor to itself. The factor to itself. Any number is a factor to itself, and any number is a multiple to itself. Okay. Now we go to the relationship now relating numbers. So 2 is a factor of this. 2 is down, which is a factor of 4. 2 is also a factor of 8. Is there anything that is a factor of anything? So 2 is a factor of 4 and 8. That's it. That's all. Then 3, from here, 3 is a factor of 9. Is there anything else? So I think that's all. So those are the factors. A factor is a number that divides that number, any number, without giving any remainder. So those are the things we have there. So these ones are having no any factors to which they are in this set. Any numbers. So that's it. When you come to this now, you use the papygram to define the relation. Use it. Okay. First of all, we start with 1. 1 is equal to itself, meaning the possibility you have there, it can be a factor. It can be multiple. It can be a square because when you square 1, you get 1. It can be a cube because when you cube 1, you get 1. So there are many. By now, I'm going to remove one by one. 1 is a factor to any number. So this would have been related to all these ones. So it's not now a factor of. I'm seeing the other one is 6. 16 is a multiple of 12 and it's not related, so that's not a multiple. Then I'm seeing 3 to 9 is not a cube, so I remove also that factor. Now I'm seeing what about the square? 1 is a square of itself, but 2 is not a square of 4. No, 2 is not a square of 4. 4 is not a square of 15. 5 is not a square of 25. Now here, it's that 4 is a square of 2. 9 is a square of 3. But here, now, they are showing that 9 from 3 to 9. So that doesn't mean it's a square. Now, you see that the only thing we are remaining with, you see, they are alternating from small to big. Small to big. Small to big. The only thing is that, what's the relation? Is that it would have been a square, because it's that 16 is a square of this. 9 is a square of this. Now, 1 is a square of 1. 25 is the square of this, but they are reversing now. It means that if we are reversing the square, it means that we are getting a square root. So the relation used was square root of. They are reversing the square. So that's how we define that. Use the papygram to draw a papygram of a relation to root. Okay, to root. Now I have 1, I have 3, I have 27, I have 2, I have 8, I have 4, then I have 64. There. Those are the ones. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. First brace up, then you put in those elements. Okay, cube root of. First of all, cube numbers, you know that cube numbers are when you square, when you cube 1, you get 1. When you cube 2, you get 8. When you cube 3, you get 27. When you cube 4, you get 64. So these are cube numbers. So the square root, the cube root means that they are reversing. So it's that A cube root of 1 is the 1 itself. Cube root of 27 is a 3. So 3 is cube root 27, as simple as that. So 3 is the cube root of 27. Then 4 is the cube root of 64. And then 2 is a cube root of 8. Why? When I get this cube root of 8, I get 2. So 2 is the cube root of 8. 4 is the cube root of this. If it was now, if the relation was cube of, if it was cube of, for example, cube of, now you see that 64 is a cube of 4. If that was the relationship. But this time, cube root. Now, whenever you get a root, you are reversing. So, we are reversing this to this. That's why 4 is coming now 64. Okay. Do a papygram for set n. We have n, 1, 3, then 2. A relation of greater than. Start 3 is greater than 2. 3 is greater than 1. Then 2 is greater than 1 also. Is there anything else? I don't think so. So that's all. That's how you can draw that. Yeah. 3 is greater than 2. 3 is greater than 3. 2 is greater than this. And that's all. So that's how you draw a papygram for greater than. So that's it, members. I wish you well.